All right, good morning, class. Today we're going to talk about transformations. We're going to talk about two transformations in particular, translations and reflections. Next class we'll talk about rotations specifically and glide reflections. All right, your original image, as it says right here, is called the pre-image. Okay, remember you should be writing all this down, so if you need to pause the video, write it down first and then go ahead and listen to the video. Okay, so notice right here, pre-image, this is the original picture. When I move it, in this case, this is a translation, I'll slid it. Another word for translation is slide. The final image is called the image. So these are two key vocab words, pre-image and image. Pre, just think, pre means before. So obviously it's going to be before the final image. This is the first one, this is the second one. Original, ending one. Okay, below are some types of transformations. Like I said, I've only copied down the translations and reflections. Okay, we'll talk about the rotations and glide reflections in this class. Okay, so a translation. Another word for that you might have learned in middle school is called a slide. Okay, that's not the proper name. The proper name is translation. A translation is two reflections over parallel lines. Okay, now do you have to know that to do the homework assignment today? No, but this definition is sometimes on the DCAS test. Okay. Now, orientation. Orientation refers to whether the figure is going clockwise or counterclockwise. If you have a figure on your assignment, you're going to be dealing with mostly points, so there's not going to be orientation with a single point. Okay, but orientation, like say we called this A, B, C, D, E. So orientation, if they ask about orientation, we talk about orientation, your only answers can be clockwise or counterclockwise. That's it. Now, if we have a translation, the orientation is going to remain the same. So if the orientation for the pre-image is clockwise, the orientation for the image is going to be clockwise. Okay, that is one way to know that the figure was transformed and it was a translation, a possibility of a translation. Versus over here in a reflection, a single reflection, okay, the orientation is going to switch. Okay, so if it started out clockwise, so here's an example. If I call this point here A, this up here B, and this over here C, when I reflect that over this line, then A prime is here, B prime is here, and C prime is down here. It's reflected over the line. Okay, so again over here we see pre-image is the original figure, image is the final figure. The image usually has what are called primes, these little apostrophes up top. That's why you see A prime, you pronounce that prime. You don't say A apostrophe, you say A prime, B prime, and C prime. Okay, so if we talk about the orientation of the pre-image, notice if I go ABC, that is clockwise. But if I look down here, A prime, B prime, C prime, this order is counterclockwise. Okay, so the orientation switched. All right, so when you have an odd number of reflections, which is since single reflection is an odd number, then it's going to switch orientation. But remember, since the definition of a translation is two reflections, that's an even number of reflections, the orientation does not switch, or it remains the same. Okay, so that's one way to help yourself identify whether something was a translation or a reflection, is by first checking its orientation, whether it remains the same or whether it switches. Okay, so now I'm talking about this. The value of checking the orientation of the pre-image to the image is that you can eliminate 2 of the 4 possible transformations. Right here, we've only talked about 2 so far. Like I said, next class we'll talk about the other 2 rotations and glide reflections. So there's a total of 4 of them. Okay, they're the 4 key ones that we're going to focus on here. 2 of them are eliminated by just knowing the orientation of the figure from the pre-image to the image. The other 2 transformations are rotation and glide reflection. If the orientation remains the same from the pre-image to the image, as I talked about here, then the 2 possibilities are translation or rotation. We'll talk about the rotation tomorrow. So we've got it down to 2 of them, just so if we know the orientation stays the same. If the orientation switches, then you have either a single reflection like this one, or you'll have a glide reflection. The other one we'll talk about tomorrow, next class. Okay, so that helps out significantly. Now let's go ahead and look at some examples of translations on this page, and we'll do reflections on the next page. So here we go. And we have the point A, which is at the point negative 5, 5. So I would plot negative 5, 5. 1, 2, 3, 4, 5. So I can do it again. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. This right here, this setup, this format is called a translation rule. In a translation rule, you always have to start with X comma Y like this. Then you put an arrow like that. And then this tells me how to translate it. Very easy. It says add 2 to each X coordinate. In this case, we only have 1 point we're dealing with. So we add 2 to the X coordinate, and we subtract 3 from the Y coordinate. Okay, this is what all translation rules that you're probably going to deal with on the DCAS are going to look like. Okay, so it just says take this point and go 2 to the right, because I'm adding 2 to the X coordinate. Let me change the color here. 2 to the right, 1, 2, and 3 down. 1, 2, 3, right there. That's it. Now remember, the original point was called A, so we put the A right there. And if we recall from right up here, remember I said with the image, you add the prime onto it. So this is called A prime right there. Prime. Have the apostrophe on there. Okay, so that point is A prime. So if you were to see this, by seeing the prime, you know that's the image automatically. If it's got a prime on it, that was the image. The letters, the out primes, those are the pre-image points, the original. Okay. So now I just gave you 1 point. They could give you a triangle, for example, or a quadrilateral, and you have all 4 points here, and you still do the same thing. You go right 2, down 3 with every point. Okay, and then reconnect them if there's a figure. Okay. Another way of identifying a translation, if they use a capital T and they put it in the subscripts, that's a negative 1 comma 3. So it's like X comma Y. That would be saying going left 1 or subtract 1 from the X and add 3 to the Y. So that means it goes left 1 and up 3, because the Y direction is up or down. Since it's positive, it is up. So let's plot that point, 3, negative 3. 1, 2, 3, 1, 2, 3. And now it tells me for the translation to go left 1, up 3. Left 1, up 3. Right there. And if they don't give you a name of the point, like they didn't give me the name, like over here they call it A, so I had to use A and A prime. They don't give you a name, you can just call it whatever you want. So we'll just call it B this time. B is my pre-image. I got to make sure I put that with my pre-image. Oops. Go back to that, move that B, and then here's, move this down, come on, there we go, right there. And then this was B prime. Okay, pre-image, original, image, final. Okay. Now, another way they could ask you a question in all these 3 examples, these are 3 types you're going to see on your worksheet. That's why I can actually copy these right off your worksheet. There's different numbers. Okay, these are 3 types you're going to see, and you can see this on the DCAS as well, where they just give you the points in point format. They don't have them graphed for you, and they want you to write the rule. Remember, this is how you write the rule that we have right here. They want you to fill in the H and the K. What direction is it moving, the X and the Y? So, of course, I always start out with X comma Y for my translation rule, arrow, then X, and I ask myself, remember A is the pre-image, here is the image. So I started at negative 2 on the X, I went to 8. How many did I have to add to negative 2 to get 8? Obviously, I had to add 10. Negative 2 plus 10. Oops, forgot the plus sign. Negative 2 plus 10 is 8. And now I ask myself, how many did I add to the Y coordinate or subtract from the Y coordinate? In this case, I added. I went from 2 to 3. I added 1 to the Y coordinate. So therefore, it is Y plus 1. And there's your translation rule. That's simple. Now, if you don't want to ask how much I add -2 to what number to get 8, I can always start at the image and just subtract backwards, and that will give me the answer right there. So if I go 8 minus a -2, that's 10, so plus 10. And 3 minus 2 is 1, so I added 1. That's the other way. If you want to subtract going image minus pre-image, that'll give you your H and the K as well. Okay, so there are translations, the 3 key ways and 3 main things you're going to be asked about translations. Okay, so now we go to reflections. So go ahead and pause the video to copy down all this information, and then just hit play again after you've got this copy down so you can just listen afterwards as I explain it. Okay, so on reflections, again, we're just talking about a single reflection. So with only one reflection, these are the 5 main ones that they're going to usually ask you, but then we're going to talk about other lines as well. So first one they might ask is reflect a point or a figure over the x-axis. First off, you have to know the x-axis is the horizontal one. Okay, so we have an example right here. Notice A right here is 2, 3. Notice there's no prime on that, so that tells me that's the pre-image. If I reflect 2, 3 over the x-axis, when I do a reflection, as it says up here, reflections are at 90 degrees to the line of reflection. So I can't come over here at this angle, that's not 90 degrees. So we're at 90 degrees to the line of reflection and the same distance away on both sides. So since all I have to do is go vertically down, that's 90 degrees, I just got to count. I went down 1, 2, 3 to get to that line. So I go down 3 more. 1, 2, 3. And there's my point reflected over the line, over the x-axis. Now notice up here, I reminded you the equation of the x-axis. If you forgot this from Algebra 1 class. If they don't say x-axis, they could always just say the line y equals 0. You need to know the line y equals 0 is the x-axis. They're the same thing. Okay, so you have to be familiar with both ways. They ask you that on the DCAS. Okay. And on your worksheet, I write them in equation format only, I think. Or I think I might do both, between x-axis and y equals 0. Okay, to make sure you know both ways, that they're the same. Okay, so again, that's very easy to count because it's already at 90 degrees. It's that line. Okay, so as it says right here, AB is the same thing as x comma y. So telling you what the final image will be. It's always, the x is not going to change because A to A, but the B becomes the opposite, becomes negative. So notice 2, 3 became 2, -3. The only thing that changed was the y coordinate became the opposite. That's what the rule is right here. That's called the reflection rule, if you want to think of it that way. Like if we had the translation rule on the prior page, this would be the reflection rule. Okay, I always just say xy goes to x comma -y. They're just using A and B, same thing. Okay, next one, the y-axis. Obviously, I know the y-axis is the vertical one. Here's an example here. If we start at the pre-image being 3, 2, and reflect it over the y-axis, again, it has to be at 90 degrees, which it is when I go straight across here horizontally, and the same distance. So what is that distance? 1, 2, 3. So I count 1, 2, 3. And there's my A prime. Notice that says A prime right there, -3, 2. So if I look at the pre-image point, 3, 2, and the final image point, -3, 2, what has changed? Did the y's change? No. That's why you don't see the b's changing. They're the same. What switched? The x became opposite. So the x or the A becomes opposite of A. That's your rule, and reflect over the y-axis. And then again, if you forgot, the equation for the y-axis is x equals 0. Okay? So x equals 0, y-axis, same thing. You got to know that. It's Algebra 1. Okay, next one is the origins. They want you to reflect it over the origin. Okay, now we'll be talking about this tomorrow. A reflection over the origin also is a rotation of 180 degrees when we talk about rotations tomorrow. So rotation of 180 degrees about the origin, same thing as reflecting it over the origin. Okay, so what is the rule? Again, if I start with my pre-image point A, B, or x comma y, so here we look at their A, 3, 2, it just tells me to do the opposite on both of them. So 3, 2 becomes -3, -2. That's simple. Now, an easy way to tell to make sure you plotted it right, if you're plotting it, and it could be, like I said, it could be an entire quadrilateral or a triangle. We're just doing it testing. We're just doing it with 1 point, but they could ask you to do it with 4 points. You do the same thing on all 4 points. That doesn't change. Every point just becomes negative x, negative y. Okay, but to visually see it, if you want to take your ruler, for example, if I connect my pre-image to my image right there, if I'd done it right, let me try doing it again here. Segment, let's change it to a segment. 3, 2, should be, why do we have this? Okay. Do they have -3? Ah, I see what happened. Okay. Notice when I connected this, I was wondering what was wrong. Can you notice when I connected this? Does this go through the origin? Does this come right here, right through the origin? No. So I'm thinking, what am I doing wrong? I'm not doing anything wrong. Look at this point right here. -3, -2. They plotted it wrong. So it's an error for them in the book. Okay, -3, 1, 2, 3, -2 is right there. They plotted -3, -2 wrong. That's why it was messed up. I was trying to figure out why that was not working. So -3, 1, 2, 3, -2 is right there. That's where A prime should have been plotted. So there's an error. They would have missed. So I'll just tell you, like if you had done something like this on a quiz, you wrote down the right answer of -3, -2, but you plotted the point wrong. I'd give you half a credit because you actually did name it right. So you got that part right. You did something right by naming it right, but you plotted it wrong. So I have to take off a point for not plotting it right. So they would have lost a point in this case for plotting it wrong in this book. So now let's go back to what it should have looked like. So if I take a ruler and I go ahead and connect that pre-image to the image, notice what does it go right through? What is that point called? What is that point right there called? The origin. So if you reflect it over the origin, and if I connect any of my pre-image points to my image points, they will go right through the origin if you actually plotted it right. Obviously, they had plotted it wrong in this example on the book here. Okay, that's why it wasn't going through the origin. But that's an easy way for you to test. And so, for example, on the DCAS, if they say rotate at 180 degrees, remember I told you rotation of 180 degrees, or rotate it about the origin, that means the same thing. I could just take my pre-image point, draw a line through the origin, and come over here, and it's got to be the same distance away. That same has to be the exact same distance over here. And I could do that with every one of my points. It has to go right through the origin. So that's an easy way for you to test to make sure you plotted things right. Okay, or especially if you forgot that rotation or about the origin 180 degrees, or this reflection of the origin is -A, -B, or -X, -Y. Okay, so that was a good way to show an error in the book. Okay, all right, next one is y equals x. Y equals x is the most famous line in math. It's this line right here. That's why you see me writing y equals x up here. It's at 45 degrees through the origin. This angle. Remember, here's 0 degrees. Here's 90 degrees. Remember, we talked about 0, 90, 180, 270, 360. You can see it splits it right in half. It's right between 0 and 90. That means 45 degrees. So from there to there is 45 degrees. Slope is 1. Y, remember, from algebra 1, the slope is the y equals mx. M is the coefficient of the x, and in this case it's 1. So you go up 1, right 1, up 1, right 1, up 1, right 1, etc. Or down 1, left 1. Okay, there's the line y equals x. Okay, so if we take a point, okay, and they went ahead and used 1, 3 right here, okay, and we're reflecting over this line. Remember, reflections must be at 90 degrees. So I have to go 90 degrees to that line and the same distance away. Okay, so as you see, when they did that, they reflected 90 degrees and it came right down here. Okay, so if we look at the original point, the pre-image point was 1, 3, and the image was 3, 1. So how did they switch? What happened here? the x and y just switch coordinates. So that's why you see when we reflect over the line y equals x, AB or XY becomes YX. Okay, you just have to switch the coordinates. X and Y switch. Again, remember, since if I connect that free image to the image, remember it must be at 90 degrees. You can tell it's 90 degrees right there. It must be at 90 degrees to the line of reflection. That is 90 degrees. So, for example, if you thought your answer was somewhere like down here, okay, if I look at that, I should be able to see that that is not 90 degrees to that line. So that would tell me my answer down here is wrong. It has to be at 90 degrees to the line, which it was right there, and the same distance on both sides. Okay, and that's how you know you're right, and guarantee you're right by doing it like that. Okay, so you want to memorize y equals x, reflect over the line y equals x. All you do is switch the x and y coordinates. That's it. Okay, the last one that they didn't put in the book here, but is often given and is put on the DCAS, is over the line y equals negative x. That is this line. That's why I added this in here. Okay, this book only covered these four. We got to add in this one because I've seen this on the DCAS. Y equals negative x. Okay, that line right there. That'd be like the second most famous line. Y equals x, most famous line. Okay, all right. So what do we have here? I took problem over here. So what I showed you, so even though I've written down the rule right here, I'm going to show you this time on how you can come up with the rule yourself. Okay, so watch this. I pick any point near this line, or near line y equals negative x. So I picked negative 1, 2. That point right there is negative 1, 2. That says negative 1, 2 right here. It's hard to see it, but that says negative 1, 2 for A. When I reflect that over that line, remember it's got to be at 90 degrees right here and the same distance. That puts it right down here to that point, negative 2, 1. Okay, let's look at what is that point called right there, negative 2, 1. So I do have to be able to identify points correctly from middle school. Okay, so this negative 1, 2 became negative 2, 1. Well, what happened? Not only did the x and y switch, but they also took the opposite signs of each. So your xy became negative y comma negative x. Okay, sometimes some people have difficulty remembering that, just the negative y, negative x. So if you have difficulty remembering that, you can just come up with this rule yourself by plotting a point right near that line that you're reflecting over, actually reflect it over it yourself, and write the coordinates of each of those, the parameters of the image point, and see how it changed. And you can then come up with that negative y, negative x yourself. Okay, if you don't want to have to do that, then just straight memorize negative y, negative x for the answer when you reflect over the line negative, or y equals negative x there. Okay, so those are the 5, 1, 2, 3, 4, 5 main ones that they are guaranteed going to ask you on the DCAS. Okay, they may not ask all 5, but of the, because you're going to have multiple ones of these problems on DCAS, just so you know. They'll give you probably 3 or 4 of these types between the reflections, translations, rotations. They're going to have probably about 5 problems on that, on the DCAS. So they're guaranteed going to have probably 3 of these 5 right here for sure. The other one that they might give you is that they reflected over any other vertical or horizontal line. So I am going ahead and going to give 3 examples from the worksheet that you're going to get. Okay, this is what it's going to look like on the worksheet itself. So let's recall here, orientation, remember, is either clockwise or counterclockwise. Okay, and that's when it's speaking of a figure. Obviously, you don't have counterclockwise or clockwise on a single point at all. Okay, we're talking about, like a triangle or a quadrilateral. Okay, and we'll look more at specific examples of those in class. Okay, I'm just not putting on the video here. Go and do it in class. All right, reflection. A reflection is a single reflection. So these reflections are single reflections. I'm not reflecting over 2 different lines. I'm only reflecting over a single line. And a glide reflection, which we're going to talk about next class, is 3 reflections. So either 1 or 3. They will always switch the orientation if you have a figure from clockwise to counterclockwise, as it says here. Okay, and I define what a glide reflection is here for you, which again we're going to talk about next class. So just write it down. Okay, and then we'll look at the figure. A glide reflection is a single reflection doing one of these, followed by a translation. Remember, a translation from the prior page is a just sliding of the figure, which technically by definition is two reflections over parallel lines. So we have two reflections with a translation plus the single reflection, one of these type, for a total of three reflections. Okay, 2 plus 1 is 3. So we have an odd number of reflections, so it switches orientation for these two. If the orientation from the pre-image to the image remain the same, then we know it's either a rotation or a translation. Okay? And rotations we'll talk about next class. All right, so next thing, vocab-wise, little r. I wrote it up here. Little r refers to reflection. So notice these are little r's right here. That's a little r, and then subscript x equals -2. The line x equals -2. So it says reflect, little r stands for reflection, over the line x equals -2. Well, you need to remember from Algebra 1 that x equals a number is a vertical line. Remember I just talked about x equaling 0 is the y-axis. So then if I just shifted x equals 1, 2, 3, 4. So x equals 1 is a vertical line right here. X equals 2, x equals 3, x equals 10. The vertical line right here. Well, we're talking about x equals -2. So that means obviously 2 to the left of x equals 0. So I have x equals -2 right there. That's the line x equals -2. Okay, and it says to, I'm going to shift that just slightly to get it, see if I can get it right on the, that's 1, there's 2 right there. Okay, that looks pretty good. All right, now it says take the point -4, -3. So I plot the point -4, there's -2, -3, -4, -1, 2, 3. -4, -3. So it says take that point and reflect it over this line x equals -2. Well, remember reflections must be at 90 degrees. Well, if I just go horizontal here, that is 90 degrees. And it must be the same distance. So since I count 1, 2 to get to the line, I must go 1, 2 on the other side of the line. And there's my image point right there. Okay, so there's my image. And what is that point? 0, -3. So my answer would be 0, -3. This is my pre-image, -4, -3. That was my pre-image point. My original, -4, -3, I plotted it, reflected over, it was 2 away, so I had to go 2 to the other side. That is 0, -3. There's my image point. That'd be my answer. I want you plotting it and naming the point on the line. Name the pre-image point as well. So I don't want you to see dots. I want to see the actual coordinates written on your paper. You know, this is a problem right from your worksheet. Okay, here we have a segment. Notice it says right here in black right here, it says reflect the following segments over the following lines. So this is segment AB. Okay, now it says, remember little r is reflection again, and then subscript says y equals x. Right there, the line y equals x, that line right there. But this, you see this little circle right here in the middle? As I say up here, that means following. That little circle means following. So it says reflect over the line y equals x following the reflection over the line x equals -2. So if something follows something, that means the one on the other side, this right side, we're doing first. So in this is called function notation, just so you know, you're getting function notation more in Algebra 2 class. Anyway, this means to do what's on the right first, do this reflection first, then do the second reflection on the left next. Okay, now on the DCAS, they will often just write it out for you and tell you. They'll say first, they'll say reflect over the line x equals 2 first, and then reflect over the line y equals x. So you will do these two things, these two reflections on the DCAS, but they won't have it written in this format. They'll actually just write it out in words, what it means to do for you and tell you directly what to do. But this is the short notation to say the same thing instead of writing it all out in words. So we need to reflect this segment over the line x equals -2. Obviously, that's the same line as this right here. Okay, it could have been a different line, just happened to be the same randomly generated. Okay, so there's x equals -2. Okay, and we need to plot the points. 3, 4. Okay, is 1, So 1, 2, 3, 1, 2, 3, 4, 3, 4, and the other one is 1, 2. 1, comma 2, right there. Okay, so we plot that, take our ruler, have it as a segment, yes. Take the ruler, dang it, connect them. Okay, and then I'm going to take that segment and reflect it over this line. That's the first one I'm doing. Remember, I'm going right to left. So I'm reflecting over line x equals -2. Okay, so again, horizontally is the 90 degrees, and I just count out the distance. So how far is it? 1, 2, 1, 2, 3. So I just go 1, 2, 3, right there. Close enough. You can do it better on your own paper. And then here, how far is this? 1, 2, 3. So 4, 5. So there's a total of 5 to get to the line. So I must go 5 back. Remember that right now is -2, so I'm going back to -7. 5 more back. 1, 2, 3, 4, 5. -7. Okay, there's -7. And then I go ahead and reconnect with my ruler. Okay, so there's the first reflection. That reflects to right there. Okay. Now the second one says take this reflection and reflect over the line y equals x. Okay, remember here's the line y equals x right here. So I put that in there. Can I change the color here? Y equals -x. That's too thick. Undo that. Okay, can we get something smaller here? Let's go like that. That's pretty big, but okay. Y equals x. Now I can, if I want to, I can draw the line like that just so you can visually check it afterwards that I reflected it correctly. Or remember, when I reflect over the line y equals x, all I'm doing is switching the x and y coordinates up here. So if I go ahead, which I should do, which I didn't do right here, is actually go ahead and name these coordinates over here. So what is this coordinate right here? -2, -3, -4, -5, 3. So let me label that -5, 3. Okay, for the bottom point right there. And the top point was -7, 5. No, 4. Yeah, -7, 4. -7, 4. Oops, that says -8. -7, 4. Right, type -8. Okay, so that's that point and that's that point. Okay. Oh, wait a second. This should be 3, 4. So 4 is height. This is 1, 2. This should be a height of 2, not a 3. That's a 2 right there. Height is 2 for the y. Okay, so I got to make sure I name them correctly. The y value height didn't change right there for that. Okay, so -5, 2 and -7, 4. Now, if I just go ahead and use this rule, it just says to switch the x and y coordinates. That's it. So this negative just says switch the x and y coordinates. So it becomes 2, -5. So I plot 2, 1. Okay, 2. There's 0, 1, 2, -5. 1, 2, 3, 4, 5. Okay. Uh, because this, don't forget, this is off right here. This should be right like that. Okay, now if I look, that looks like 90 degrees in the same distance away. Okay, remember it's going to be 90 degrees to the line and same distance. And then here I switch the x and the y, so it becomes 4, -7. So now I plot 4, -7. There was 2, 3, 4, and that was -5. I got to go down 2 more, -7 right there. Okay, and there is, oops, undo that segment again. Oh, just erase my point. Let's put that back in there. Okay, 4, -7, 2 more down. Okay, now take the ruler and reconnect right there. Okay, so that is letting you know that this reflected over this and landed right there. Okay, that reflected over the line y equals x, landed right there. So here's my final image right here. So notice I have the pre-image, I have an original image. Now, if I was to put letters on this, just notice that I did 2. Remember, the original has no primes on it, so that'd be like A. So if I go ahead and name them right here, A was 3, 4. So there is A. Let's practice writing our primes. A. B is right here, our second letter. 1, 2 right there, our second point. 1, 2. Well, that very first reflection over line x equals -2. Now these become A prime, because that's my first time I've done it, so it gets a single prime. And that becomes B prime, because that's the first time I've reflected something. Okay, oops. Go back to that. Okay, B prime right there. Well, now, since I'm reflecting that one again, that one goes to here. This one becomes B double prime, because I've done a second reflection. I don't do a single prime again. The first one gets the first prime. The second one gets the second prime. Remember, that's like when we talk about hash marks and all that kind of stuff in our triangles or arcs. You don't repeat things. Okay, and then this A prime got reflected down to here to become A double prime. That's how you pronounce it. Oops, A double prime. You don't say A hash mark, something like that. Dang it. A double prime is how you pronounce it. Okay, and there's that point right there. So here's my final image. So just by looking at this, I can see, if I didn't even know what the problem was, I can look and say, okay, there's no primes here, so this was this person's pre-image. This was their first reflection because it's got a single prime, and this was their second reflection to get down here because it's got double primes on it. So I can easily tell which order that they did their reflections in, okay, from that. All right, last example, which is similar to this one right here, okay. We have -3, -3. 1, 2, 3, -3. 1, 2, 3, -3. That's A. Put the point next to it. A there. B says 3, 2. So plot 3, 2. 1, 2, 3, 1, 2, right there. That's B. Put a B next to it. Oops, not JB, BHB. Okay. Now it goes ahead and says, remember we do that little circle means following, so we do what's on the right first. So it's reflect over the x-axis. You're going to have one like this on the DCAS. Okay, reflect over the x-axis. They'll write out the whole words. Reflection over the x-axis. Okay, instead of little r. Okay, so reflect both these points over the x-axis. Remember, this is the x-axis right here. So I just reflect this over. Count how far to get there and go down. So it took me 2 to get there, so I go down 2. 1, 2. So I go down 2 more. 1, 2. There's B prime. Right there, B prime. Oops, B prime for that point. And reflect this over the x-axis. So just count up. All I'm doing is counting. 1, 2, 3. So I got to go up 3 more. 1, 2, 3. Right there. A prime. Because that's my first reflection. So it's a single prime. Okay, now it says to reflect over line y equals -x. Remember, y equals -x is this line right here. Coming right down through here. We can either draw that line or we can just use the rule. So here's the rule for reflect over line y equals -x. So here's line y equals -x. Here's my rule. It says do the xy becomes -y, -x. So let's go ahead and name these points right here. That's -3, +3 right there. -3, +3 for that point. And this point is 3, -2. 3, -2. Okay, for my B prime. So now it tells me exactly what to do. If I want to reflect over this line, y equals negative x right here, all I do is do negative y comma negative x. So negative y, so I'm gonna write off to the side here, a double prime equals, remember, negative y, so the y is 3, so negative y is negative 3, oops, negative 3, and then negative x, it says. Negative, or the opposite of x, is positive 3. I'm just writing them over here to begin with, because then it's easier then to go back and just plot it on here. Okay, and then b double prime, there's double prime, equals, again, negative y, so the negative y here, opposite of y is positive 2, and the opposite of x, or negative x, same thing, opposite of the x here is negative 3. So that tells me now to plot these 2 points, and those become my a prime and a double prime. I'm an a double prime, b double prime. Okay, so negative 3, 3. Notice negative 3, 3 is the exact same point as a prime. Okay, and why is that? Because it lands right on the line of y equals negative x. So if something is actually on the line itself, it reflects right back onto the line. That's why that ends up being the exact same point. Okay, this b prime is not on the line, so that's why it did change. So it became 2, negative 3. So I plot 2, negative 3. 1, 2, 3. 2, negative 3 right there. Okay, and that becomes my b double prime. B double prime. Okay, so you can see it's easier if you just memorize these particular rules. Okay, y equals x, switch the x and the y equals negative x, switch the x and the y and add negatives on both of them. If it's about the origin, you just put negatives on both of them. If it's about the y-axis, you just put a negative on the x. If it's about the x-axis, you just put a negative on the y. That's it. So it's easiest just use those rules. But if you have to draw the lines and actually just count, as I showed you in these examples, you can just count across as well. All right, that ends the lesson for today. Like I said, tomorrow, next class, we'll talk about rotations and glider reflections.